humans will travel to Mars within the next couple of decades. That's according to NASA anyway. The ultimate goal? To live entirely independent of Earth. Scientists are already developing technology that will enable us to travel the incredibly long distances and keep us alive when we get there. But if we really want to inhabit other worlds, a major issue needs to be addressed. Can we reproduce in space? If humans had a base on Mars, we couldn't keep popping back 225 million kilometers, a journey likely to take around 7 months, to have children on Earth. Humans will need to have babies in space. But space is a hostile environment for the human body, with high levels of radiation, something both sperm and egg cells are highly sensitive to. NASA recently sent the first samples of frozen human sperm to space. The frozen cells were successfully reactivated but showed DNA damage and moved differently, which would likely reduce their chances of fertilizing an egg. More encouragingly, freeze-dried mouse sperm that spent several months in space produced a brood of healthy pups when fertilized back on Earth. Although the sperm DNA had changed, the damage was repaired upon contact with the female egg. For a fetus to develop in space, however, it would need to be protected from this harmful radiation. Its rapid growth rate would make a baby particularly vulnerable to genetic mutations, increasing the risk of childhood cancers. And perhaps as significant as radiation in the long term is time spent away from Earth's gravity. We know that low gravity causes astronauts' muscles to atrophy, bones to become less dense, and the quantity of circulating blood in the body to decrease. The first baby born off planet Earth will most likely be born on Mars, where gravity is about 38% of Earth's, which is bound to affect both birth and development. But if a child was born in microgravity, for example on a space station, the impacts would be much more pronounced. For the sake of argument, let's imagine this happening. It's thought that gravity helps shape parts of the inner ear that play an important role in balance and orientation. Rat pups born after developing in space couldn't sense which way was up or down, and microgravity would continue to pose challenges for childbirth itself. On Earth, there is always the option of a C-section, but although medics have mended rats' tails and performed keyhole surgery on pigs, no one has ever been operated on in space. Blood can spatter even more than it usually does on Earth, floating around unconstrained by gravity. Or it can pool into a kind of dome around a wound, making it hard to see what's going on. Today, if an astronaut needs emergency surgery, they have to ditch their mission and return to Earth. But presuming the birth was successful, a baby growing up in microgravity would look, move, and behave very differently to one born on Earth. There, a child would not learn to crawl, but would instead learn to float, propelling themselves using their arms. Without a strict exercise regime, it's possible their bones and muscles would be smaller in their lower body, yet bigger and stronger in their upper body. Like astronauts, fluids in their body could travel upwards into their chest and head, giving them a puffy face. As a result, a child born and raised in space might never be able to live on Earth. It's possible they might not be able to walk, stand, or even breathe. Earth's gravity is so important to humans that it's been described as the identity of mankind. Without it, would a human subspecies emerge, only able to survive in space? Assuming all the physical challenges can be overcome, there are other issues that would need to be considered. What would be the impacts of raising a child in such an isolated and extreme environment? While a mother may be able to consent, the child cannot. Is it ethical to raise human beings who may never be able to set foot on planet Earth? Right now, having a baby in space may feel like something from a sci-fi film, but ultimately, it's a puzzle we have to solve if we want to travel deeper into our solar system.